Our story begins millions of years ago, in the vast and diverse landscapes of Africa. This ancient continent, often called the cradle of humanity, holds within its soil the secrets of our earliest ancestors. In today's video, we'll dive deep into the origins of human evolution, starting in a time known as the Miocene epoch, an era where the evolutionary paths of humans and apes first began to diverge. The Miocene epoch, which lasted from about 23 to 5 million years ago, was a pivotal period in the history of life on Earth. During this time, apes flourished. Africa was largely covered in dense forests, and our distant primate relatives thrived within this ecosystem. Fossil evidence from this era shows us that apes were diverse in shape and size, inhabiting forests across Africa, Europe, and Asia. These apes are the ancestors not only of modern humans, but also of the chimpanzees and gorillas we know today. However, the world was about to change. Climate shifts caused the vast Miocene forests to shrink, gradually giving way to more open grasslands. For many species of apes, this environmental transformation proved too difficult to survive. But for some, it created the conditions for adaptation and survival. This is where our story truly begins. As the forests receded, a new type of primate emerged, the hominins. These early ancestors of humans didn't remain tied to the shrinking trees. They began to venture out into the open landscapes, evolving to walk upright on two legs. This adaptation, known as bipedalism, marked a defining moment in our evolutionary history. But why did bipedalism evolve? Walking upright freed up the hands, allowing hominins to carry food, gather resources, and eventually create tools. It also enabled them to see over tall grasses, making it easier to spot predators. This wasn't just an accident of evolution. It was an incredible adaptation that would lead to the development of more complex behaviors over time. One of the earliest hominins we know of is Sahelanthropus cadensis, who lived around 6 to 7 million years ago. Though it walked on two legs, its skull still resembled that of a modern chimpanzee, showing how slow and gradual this transition was. Fast forward to about 3.2 million years ago, and we arrive at one of the most famous hominin species, Australopithecus afarensis star. You might have heard of Lucy, one of the most complete and iconic fossil skeletons ever found. Lucy's discovery in Ethiopia in 1974 by paleoanthropologist Donald Johanson transformed our understanding of early human evolution. Lucy, though short by modern standards at just over 3 feet tall, was already walking upright on two legs. Her bipedalism, seen clearly in the structure of her hips, knees, and feet, signaled a major shift in hominin evolution. Unlike other apes that relied on knuckle walking or climbing trees for survival, Lucy's species had adapted to life on the ground. But why did bipedalism become such an essential adaptation? Some scientists believe it was related to energy efficiency. Walking on two legs, especially in a changing environment, may have allowed early hominins to travel longer distances while using less energy. Others suggest that bipedalism evolved as a way to carry tools and food, giving early humans the freedom to multitask in their environment. Lucy's species lived in a world that was transforming, a world where the ability to walk, gather, and survive in the open grasslands was crucial for survival. But bipedalism was only one piece of the puzzle. Around 2.6 million years ago, another breakthrough occurred, the development of stone tools. This technological leap is referred to as Oldowan technology, named after the site of Olduvai Gorge in East Africa where some of the earliest tools were discovered. These tools were simple, often just a sharp edge made by striking two stones together, but they gave early hominins a distinct advantage. With these tools, early humans could cut meat from carcasses, process plant materials, and even defend themselves from predators. These tools also represent something more profound, the ability to think ahead. Early humans weren't just reacting to their environment, they were shaping it. Imagine a group of early hominins, perhaps Homo habilis, scavenging a large animal carcass. With their stone tools, they could access the rich, calorie-dense marrow inside bones, a resource that most other animals couldn't reach. This was a game-changer. Tools allowed hominins to survive in new ways, and their development marked the start of an intellectual journey that would eventually lead to language, art, and culture. The African landscape was as much a part of this story as the hominins themselves. Africa's environment during this period was dynamic and constantly changing. The receding forests and expanding grasslands put pressure on species to adapt or die. Those that couldn't make the transition to the new environment faded into extinction. But the hominins, thanks to their ability to walk on two legs and make tools, thrived. One of the reasons that Africa is called the cradle of humanity is because this environment forced our ancestors to innovate. With each generation, those who could adapt passed their traits down to their offspring, leading to the evolution of new species of hominins with even greater capabilities. As time passed, hominins continued to evolve. By around 2 million years ago, the first members of the genus Homo appeared. The name Homo is derived from the Latin word for human, and this group included species such as Homo habilis, known as the handyman, because of their association with toolmaking. Homo habilis was an evolutionary step closer to modern humans. With larger brains and more sophisticated tools, they were better equipped to survive in a changing world. Their cognitive abilities were also increasing. While earlier hominins may have used tools instinctively, Homo habilis was beginning to innovate, to solve problems in real time. But evolution isn't a straight line. While some species of Homo continued to adapt and evolve, others, like Australopithecus afarensis, eventually died out. The evolutionary tree of humanity has many branches, and not all of them led directly to us. Still, each of these branches contributed something to the overall picture of human evolution. How do we know all of this? How can we reconstruct the lives of creatures that lived millions of years ago? The answer lies in the fossils, bones, and tools left behind. Over the past century, archaeologists and paleoanthropologists have meticulously excavated and studied sites across Africa, piecing together the story of human evolution. Each new fossil find, each new tool, adds a piece to the puzzle. From the bones of Australopithecus to the tools of Homo habilis, we are constantly learning more about how our ancestors lived, moved, and adapted. And while there are still many unanswered questions, like what drove the development of language or complex societies, the fossils we have already tell a story of survival, adaptability, and intelligence. Today, the legacy of these early hominins lives on in us. From the way we walk, to the tools we use, to our ability to innovate and problem solve, these traits were first developed millions of years ago in the African savanna. The story of human evolution is not just about biology. It's about the choices our ancestors made, the challenges they faced, and the environments they adapted to. As we continue to explore our origins, we come closer to understanding what it truly means to be human. From the first steps taken by Lucy's kind to the complex societies we live in today, our journey is one of constant change and evolution. Thank you for joining us on this journey through time. Stay tuned for more as we continue to uncover the story of human evolution, one fossil at a time. Don't forget to subscribe for more explorations into our ancient past. We'd love to hear your thoughts on possible future topics. What areas of human evolution would you like to explore next? Leave your suggestions in the comments, and let's keep the conversation going. As always, our references and further reading are listed in the description below if you'd like to dive deeper into the subject. Thanks for watching, and we'll see you in the next episode.